So in this case, I'm going to replace my x to the 1/3 with a. So that if I square both sides, I can see, hopefully you can hopefully see that if I square the left side there, I get x to the 2/3, and to the right side I get a squared. So these two expressions can be used to replace all the x's in the equation. So it'll be 6a squared minus a equals 12. So 6a squared minus a minus 12 equals 0. And I'm going to try and factor this. So 6 times 12 is 72. So what multiplies to give me negative 72 and adds together to give me negative 1? And the answer is negative 9 times 8. So I have 6a squared. I'm going to replace this negative 1a with negative 9a plus 8a minus 12 equals 0. Now, common factoring the first, I'm going to pull out a 3a, which leaves me with 2a minus 3. And in the second two terms, I'm going to pull out a 4, which also leaves me with 2a minus 3. That's promising that these two are the same because I can, again, common factor. So 2a minus 3 pulled out of the first term leaves me with 3a. Pulling out of the second term leaves me with 4 equals 0. So solving each of these brackets separately, I have 2a equals 3 and a equals 3 over 2. And on the second bracket, I'm going to have 3a equals negative 4. So a equals negative 4/3. Now, a was only temporary. So a, remember, was equal to x to the 3rd. So x to the 3rd equals 3/2. Now to get rid of that 1/3, I am going to raise it to the power of 3 over 1. And what I do to one side, I do to the other. So multiplying these two exponents, I get just x, and on the right side, I get 3 over 2 cubed, which is 3 times 3 times 3 is 27. 2 cubed is 8. So my answer, one answer is 27 over 8. And then if I do it again for the second possibility, which is x to the 1/3 equals negative 4/3, coming from right here, I'm going to cube this one and cube that one. So x equals negative 4 over 3 cubed. So x equals negative 64 over 27.